One more lesson in this sequence. There are a few integrals that can only be done by integration by parts. And I'm going to sort of call these special integrals. They're not integrals that I expect you to memorize, but I do expect you to memorize and know that integration by parts is how you get through them. The big three common ones are natural log x, the arcsine of x, and the arctangent of x. We have not ever had any method to integrate those things, but we now can using integration by parts. So we'll go through a couple of examples of those and then call it a day. So the first one, simplify the integral of the natural log of x dx. Now you may be wondering, like, how am I possibly going to use integration by parts in this? Like, are there even two things here? Because for parts you have to choose a u and you have to choose a dv, right? Well, it's a little bit sneaky. It's kind of fun. We're going to choose our u to be something I can take the derivative of, and our dv as something we can take the integral of. And I'm sure you guys are tired after the first two videos. I feel like this is really a neat problem. You're going to like this one. So for my u, I'm going to choose natural log x, right? Because I can take the derivative of natural log x. Now what does that mean my dv is? What's left over? All that's left in that integrand is dx. I'd actually invite you, like, pause the video, finish this problem. It's actually really easy now that you have this much of it. Should be easy. You've got du, which is 1 over x dx. You've got v, which is the integral of dx. The integral of dx is x, right? So now let's transform this integral. I'm supposed to transform it into uv minus the integral of v du. uv is x ln x minus the integral of v du, and here's where the magic happens. When I do v du, x times 1 over x gives me just dx. So what I end up with is x ln x minus the integral of dx is x plus c. And if you've ever wondered what the integral of natural log x is, there it is. X ln x minus x plus c. Again, not something I really expect you guys to memorize. If you do, fantastic. What's more important is that you know that if anyone ever asks you to take the integral of natural log, integration by parts is one method to get through it. And another example of where you see this happening is with arctangent. We're going to use the exact same method. So pause the video for 15 seconds and see if you can guess what you're going to use as your u and your dv. Hopefully you chose that your u is going to be arctan x, and your dv was going to be dx. Right? If you did that, now the question is, do you remember what the derivative of arctangent is? Hopefully you remember it's 1 over 1 plus x squared. And then over here, v is, no big deal, it's just x. Okay. Then, just like before, I take this thing and I use my integration by parts rule. We sort of remember to write that thing down until we have it firmly memorized. So now I'm just plugging pieces in, right? This is x arctan x minus the integral of v du. When I put those things together, I end up with x over 1 plus x squared dx. And why is that new integral so much nicer to work with? Right? The reason that new integral is so much nicer to work with is that this is going to have a U-substitution that works great for it. If I choose my u to be 1 plus x squared, my du will be 2x dx. That basically means my dx is du over 2x. So now we're sort of, we've got our x arctan x minus, and now we're going to have to work with this integral, x over u times my du over 2x. How marvelous. Those x's will divide out. I have x arctan x minus 1/2. We've got the integral of 1 over u. We might as well just do that. That's going to be the natural log of the absolute value of u, but u was 1 plus x squared plus c. And there it is. I'm not about to say that this is like the nicest, prettiest integral we've ever seen, but dude, we just took the integral of arctangent x. Like, we just got through a problem that was previously like beyond the realm of impossible. And it's amazing that we've got something that lets us do things like this now. I have one more example. If you have any mathematical fortitude left, then you're amazing. Stick around for this one. If you don't, the problem is actually really similar to the first problem. You can probably do without it. The one thing you should pay attention to is what would we have to choose as our u and as our dv here. Again, and this is key. I hope you're still here. Explain to yourself, to the screen, why you can't choose your u to be x. If you did, your dv would have to be ln x dx, and we don't really know the integral of natural log x. What would be a lot better would be to do what we did in the first problem, to choose your u as ln x and your dv as x dx. Right? If we did that, our du is just 1 over x dx, and your v is 1/2 x squared. So then when we do integration by parts, we end up with 1/2 x squared ln x minus the integral of v du. That's 1/2 x squared times 1 over x is just going to leave me with x. And notice that integral that's left over is really easy to work with. This is just going to be 1/4 x squared plus c. So integration by parts does work on those traditional problems where it's a power of x times something you can integrate, but it's also really useful for things like this where you're working with a specialized function like natural log x, arcsine, or arctangent. Get some rest. I'll see you in class soon.